Hello and welcome to the video lecture on basics of LED interfacing in 8051 microcontroller. So let us first understand what is LED. So LED stands for a light emitting diode. So it is basically a semiconductor device which emits the light when the current flows through it. Now these light emitting diodes, they are actually heavily doped PN junctions, and depending upon the type of the semiconductor material used and the amount of the doping, the LED will actually emit the colored light at a particular spectral wavelength when the device is forward biased. And normally these LEDs are encapsulated with a transparent cover so that the emitted light can come out. So see, this is the picture for LED. So this is what is a transparent cover for the LED. LED is having two terminals. One terminal is called as a anode, which is a positive terminal, and the second terminal is called as a cathode, which is called as a negative terminal. And this is a symbol of an LED. So this is represented by anode, that is a positive, and this is a cathode, which is negative. Now these LEDs are actually available in variety of sizes, like in 3 mm, 5 mm. So this 3 mm, 5 mm actually represents the diameter of the LED. And also we have seen that depending upon the different material used, the different colors LEDs are also available. So in the diagram you can see the different colors LEDs are also available. Now these are some of the advantages because of which actually we prefer the LEDs in the circuits. So it gives a low power consumption, size is very small, they have a fast switching action, they are physically very robust, and they are long lasting. If you see the application part of the LED, then you can see the LED everywhere in car, bike, street lights, home lighting. So I have listed some of the applications here, but you can see we can make use of the LEDs almost everywhere in our daily life. Now this is what is a circuit diagram when the LED is forward biased. So the anode terminal of the LED is connected with the positive terminal of the battery, and the cathode is connected to the negative terminal, which is called as a forward biasing. So whenever the voltage is applied, because of these connections, the current will start flowing through the LED, and the LED will start emitting the light. And here is a VI characteristics for different color LEDs. So depending upon the color, it is the characteristics vary slightly, but if you see the overall nature of the characteristics, then it will remain the same. And this cut-in voltage depend upon the type of the semiconductor material which is used for that particular LED manufacturing. Now let us understand how we can connect the LED with the 8051 microcontroller. So actually there are two methods by which we can connect the LED. First method is this one, in which the anode is connected to the port pin and the cathode is grounded through one series resistor, which is called as a current limiting resistor. And in the second diagram, if you can see, we can apply the input voltage here, and anode is connected to that voltage, and now cathode will be connected to the port pin of the 8051 microcontroller, through which it is grounded. So any one method is absolutely valid for interfacing of LED in 8051 microcontroller. Now here if you can see, whenever in the first case, when I want to make this LED on, then I have to apply the logic 1 here, so that my LED will be on, because logic 1 means a plus 5 volt. So when I apply the logic 1 to the port pin, then the 5 volt will be connected to the anode and the cathode is grounded, and therefore the LED will emit the light. Similarly, in the second diagram, if you can see, here I have to connect or give the logic 0 to this port pin, because I have already applied the input voltage, that is plus 5 volt, to the anode, and now for circuit completion I need a 0 volts. So if I apply 0 volt over here, then only this circuit will complete. From 5 volt to 0 volt, the current will flow and the LED will glow. So any one of the method is absolutely valid. Now see, here we have connected one series resistor for these LEDs. Now the reason is the LED requires only 10 to 15 milliampere of current for its operation with a full intensity. And if you see the port current, that is a sourcing or sinking capacity of 8051, then it is actually in the range of some 20 to 25 milliampere, and therefore in that case actually we need to limit the current, and therefore we are going to use one series resistor. Now we'll see how what should be the value of this series resistor, how it should be connected. So let us see the calculation for the series resistor. So here I have applied a plus 5 volt supply. So plus 5 volt one resistor, and then there will be a series LED connected. So whenever your LED is in the on condition, there is some forward voltage drop for that LED, and that forward voltage drop is in the range of 1.7 to 2 volt depending upon the color of the LED, and therefore you have to also consider that forward voltage for calculating the value of resistor R1 or R which is connected in the series. So voltage applied is plus 5 volt, and the R according to Ohm's law given by V is equal to IR. So R is equal to V divided by I. So R is equal to V. V means this plus 5 volt minus this forward drop of the LED when LED is in the on condition. Here I have considered it equal to 2 volts divided by I. So just now I have told you that the LED requires 15 to 20 milliamperes of current. So I have taken here 15 milliamperes. And now if you calculate the value, then it will come approximately 200 ohms. So you can go for a series resistor of 220 or maybe 330 ohm resistor is sufficient in series with your LED. So this is what is the calculation of resistor value. And if you see the power dissipation, then you can calculate it as P is equal to V into I. So voltage is now 3 volts because 5 minus 2 we have taken that drop multiplied by the current. So that is 15, so 45 milliwatt. So actually any quarter watt resistor having a wattage of 250 milliwatt is more than sufficient for this. So if you want to connect any series resistor for an LED, then in that case you may go for any resistor from 220 to 470 ohm with a power dissipation of 250 milliwatt. So this is what is a simple design of a series resistor. And now how to write the embedded C program, and how to check the output using Proteus software. So that video I have already made and I have already uploaded. So you go through my channel. I will provide the link of the same in the description box. So if you like the video, then don't forget to share and subscribe to my channel. Thank you guys. Thank you so much.